when I'm talking about the gradient, guys, I'm talking about the slope of the line. And what I mean by that, so if you have if I just draw a quick graph, a graph that's going upwards like that. There's a gradient of this slope, and we measure how steep it is. Okay, so I'm put a note here. Yep. So we measure how steep
Mr. Ezra.
is the 1 second is the slope. Okay. Okay. So we're talking about the gradient. We're looking at the slope of the line, and the graph. If you look at the graph, guys, on the right, I have drawn a graph roughly. Okay. So I'm not. It's not an accurate graph, obviously, and we are measuring. When I say the slope, we're actually measuring the steepness of this line of the slope. So imagine like you're in a snowfield and you're going down the hill on your skis. Okay, you'll go fast down if you have a steep slope. Okay, now and then you can measure that gradient. But you can probably go slow if the slope is, almost a straight line, or and you're going down slowly. So that's what we're going to measure. We're going to measure the slope, which is called the gradient of a line. And the formula for that is, let me write the formula because that's something that we're going to use. There's two formulas normally we can use. One of them is rise over run, and I'm going to explain that. That's one formula. And the other formula is y2 minus y1 over x2 minus x2, and I'm going to explain what that is as well. So you can use both of these. They're both are the same thing. We just have to, you can use whatever's easy for you, okay? So I'm just going to put numbers on the graph that I have on the side, and I'm going to explain how to use both of these formulas. So if I put 1, 2, 3, 1, 2, 3 on the graph, and if I'm going to line them up, just something like that, just so you can see what it looks like. Okay, all right. So I'm going to measure the slope, and I'm going to only pick, I'm going to use 2 points. I'm going to use that point and that point, and I'm going to do like a triangle, okay? And I'm going to use, so another word for gradient, or the letter for gradient is M. I should have mentioned that. So it's M is equal to rise over run. If you look at these 2 points, and I'm going to start from this black point, and I'm going to go to the red point there. So what's our rise? How many units has the graph is gone up by? So we're at 2. It's gone up by how many units? 1. So that's going to be 1 over run. How many units has the graph been moved to the right? When we're going from the black point to the red point, how many units has it moved?
Wait, I don't understand the question.
So from black point to the red point, how many units have we gone towards the right?
1.
1. So our gradient is 1 in this case.
Oh,
okay. Now I'm going to use the second formula, which is y2 minus y1 over x2 minus x1. In this case, I'm going to write down coordinates of each point. So I'm going to put 2 and 2, and I'm going to put 3 and 3. Okay, they're the coordinates of those 2 points. And obviously, that's going to be x value, that's going to be y value, and that's going to be y value. Okay. So if I'm going to use my x2 value, let's assume this is y2 and that's x2. Okay, you can pick any one of them, it doesn't matter. And I'm going to get my y2 value, which is 3, minus my y1 value, which is 2, divided by my x2 value, which is 3, and x1 value, which is 2. And that's going to equal to 3 minus 2 is 1, and 3 minus 2 is 1. So 1 over 1 is 1. So I can use both of the formulas, and I can get the gradient for this slope. Before I go into the next question, I want to probably explain this to you, okay? And I'm going to do a rough copy, the rough drawing, not copy. So if you have a line that's let's say that's going like that, okay? This is a positive gradient, okay? And if you had a line that's going like that, for example, that's a negative. It will give us a negative gradient, okay? And if we had a line that's straight, what do you think that's going to be? So that will be a 0 gradient. All right. Okay. So now I'm going to do a question, guys. I'm going to draw a graph, a rough graph quickly, and then we're going to use that information in the graph to solve our gradients. Quick. Oh, we need to number them first. So let's go 1, 2, 1, 2, 3, 4. Okay. And 4 there. Okay. All right. Let's draw. So I want a line that goes through 5 and 4. So I'm going to put a dot there so I can draw it properly. And I want a line that goes through here. Okay. So let's see if I can get a straight line happening. Almost straight. Okay. So we have a line that's going through a graph, and I have 2 coordinates there. For us, the gradient, I need to have. So I'm going to write the coordinate on the coordinate there. It's going to be 2 and 1 coordinate. And if I'm going to use my formula, which is m, I should write what m is equal, what it means. Okay, let's actually join them up. So let's find out from this point onwards here, what's our rise? So the rise is going to be the y-intercept. So it's gone up by how many units, guys? So it was at 1, so that's 1, and it's gone up to 4. So how many units has it gone up by? 3 units. How many units has it gone towards the right or run?
3.
Yep, 3. Good. So the 3 comes from, we start from 2, we go to 5. So they've got 3 units to the right and 3 units rise. In this case, can I actually, so our answer is going to be 3 over 3, and that's going to be 1 in this case as well. Okay. But if I use the other formula that I've given you, y2 minus y1 over x2 minus x1. And the question that you should ask me is, how do we know which one's y2 and which one's x2? It doesn't matter in this case. You have to just give it a name for any of the coordinate, and you have to pick one. So if you go to x2 for this one and xy, and that's going to be x1 and x and y1. It doesn't matter which coordinate you use. The only thing you have to be careful of, if you're using x2 for one coordinate, make sure it's y2 on the y coordinate as well, or the y-intercept as well in this case. So it's going to be y2 is going to be 4 minus 1 over 5 minus 2, and that's going to equal to 1 as well. So that will be like 3 over 3, and that will equal to 1. So in this case, our gradient is 1 again. Okay. If I draw, I'm going to draw another line on this graph. And let's draw something like this. Okay. All right. So I'm going to use this line, this dot here. I'm gonna make a dot, and I'm going to use this dot there, and the coordinate of that is going to be 6 and 2. And we're going through the same coordinate of the first one. And let's go use rise over run for this one as well. Okay, so I'm going to do this in red pen. In this question, in this red or yellow curve that I have, what's our rise, guys? We went through number 1 and we finished at number 2. So what's our rise going to be on the y-intercept? Yep, 1. What's our run? So we started from 2, we finished at 6. What's our run?
1.
No, our run is not going to be 1. So the run is the x-intercept or x-axis, and the rise is the y-axis. Okay.
Two.
So we're going from 2 to 6.
4.
How many units have we moved?
We're moving 4. We're moving 4.
Good. So that's going to be 4. So our gradient is a quarter. Now, what I want you to actually look at is, if you look at our question, our answer, it's a quarter. Is quarter really close to 0? It is close. It's close to 0, as in like the number 0.
Yeah.
Yeah, and you can see that as our number gets close to 0, our line is going to be a straight line. So it becomes more of a straight line. Can you see that?
Yeah.
So if our gradient is like 10, 11, 12, or 100, what do you think the graph or the line's going to be? Is it going to be a steep line, or is it going to be like a straight line? What do you think? So if we compare our first answer, we've got a gradient of 1. And if you compare the gradient of a quarter, what's happening? What do you think is happening here, guys? As we get closer to 0, can you see that line is getting closer to a straight line?
Yeah.
And as the number is getting greater than 0, do you think the line is becoming more steep and steep?
Yeah.
Yeah. So that's what's going to happen. If you get a big gradient, or a large gradient, for example, our line is going to be steep and steep. And if you're getting a gradient that's really close to 0, that means you're getting a straight line, almost a straight line. Okay? Does that make sense?
Yeah, that makes sense.